All right, assalamu alaikum everyone. I hope you guys are all well. We will start in a few seconds. So we were doing trigonometry and we're done with some concepts on this topic already. There is still quite a lot left. So there are a few concepts that we will be doing today, and we will see if we're able to reach graphs after that. Otherwise, we will have to discuss graphs in the next class, which will be the last session that we spend on trigonometry. So the next session is going to be the last one that we have on trigonometry. If you have any problems, please do let me know about them, because then we would move on to differentiation after this. All right, good. I think I've got everything set up now. We will begin. So we will start. We'll do a few concepts and we'll have a namaz break in about 20 minutes, inshallah. And then we will do some more concepts after that. So what have we done until now? We have talked about how to solve equations. Primarily, that was one major thing that we did. We used two things for this: basic angle and quadrants, right? We find the basic angle, first of all, by making whatever is on the right side positive and writing the angle on the left side as alpha, and then we find the basic angle, and then we know that we know which ratios are positive in each quadrant. Using that, we write down the possible answers given inside the given interval. That's one thing that we have done. Then we talked about trigonometric identities. There are two identities in particular that you need to be aware of in paper one: sine squared theta plus cos squared theta, that's identical to 1, and tan theta is identical to sine theta over cos theta. Using these two identities, you can either solve equations. So sometimes you have equations that have multiple functions. For example, we looked at these cases where we had an equation in which we had sine and cos function. We converted it to tan first of all, and then solved that equation after that. And there were some other examples that we did as well. And then towards the end of the last class, we also learned how to prove trigonometric identity. So if we have an identity given like this, how do we prove that this is true? Given these two identities, sine squared plus cos squared equals 1 and tan equals sine over cos, we start from one of these two sides. Generally, the side that is relatively more complex, we start from that side. We prove that equal to the other side, right? Using these two identities. This is what we've done until now. I hope you've done some practice questions from the worksheet as well. And if there are any problems, we might be able to look at some of them towards the end of today's class. Otherwise, we will do more practice in the next class as well. So now you were saying something, or you just got unmuted by mistake? Okay, no. All right, now let's move on to the next concept for now, and then I'll take your questions. You can post in the chat if you have any specific questions as well. I will have a look at them from the worksheet. But this is one major concept that we want to do today: solving equations involving angles that are not just theta or x. Now, what does that mean? So sometimes you would end up getting an equation that looks something like this. For instance, cos of theta plus 60, that equals, let's say, 0.85. Let's say you have an equation like this to solve, and the interval that you have for this equation is from 0 degrees to 360 degrees. So we want to solve this equation for this interval, theta between 0 and 360. Okay, is there a lot of background noise? Actually, there's some work going on um, in, I think, a nearby building. If anyone is not able to
Not really, sir.
Not really, it's okay? Okay, all right. Because I'm hearing a lot of it, so hopefully it's not passing to you guys. Okay, that's good. So cos of theta plus 60 equals 0.85. Theta is between 0 and 360. Okay, that's the interval that we're given. We want to solve this equation. Now, how do we go about this? Now, the problem in such equations is the angle is not theta. The angle is this whole thing, which is theta plus 60. This whole thing is the angle. Okay. And the interval that we're given is from 0 to 360. The interval is for theta. The interval is not for theta plus 60. The interval given is for theta plus 60. Okay. Now, how do we solve this equation? You can solve it directly as well, but if you use a substitution here, that will make things a lot easier for you. So the way I would recommend that you do it is whatever is written inside the brackets, so basically whatever the angle is, you substitute that with another letter. So you say, let another letter, let's say A, that equals theta plus 60. Okay. Now, make sure that you understand this process well, because when it gets a bit more complicated, you really need to make sure that you do it exactly like this. That will make your life easier. And this is something that is tested in paper 3 later on as well. So it's even more important for that reason, because some questions in paper 3 will also depend on this method. Okay, so what you do is, whatever is written inside the brackets, whatever is the angle, you substitute that with another letter. So you say, let A equals theta plus 60. Now, when you do that, what does your equation become? The equation is now cos of A equal to 0.85. And this is something that you know how to solve, right? Cos of A equal to 0.85. This is solvable, right? You've solved equations like this before, where there's just one angle like this. But there's another problem, and the problem is the interval given was for theta, and we are solving this in terms of A now. So we also have to adjust this interval. So we have to write down the interval in terms of A first of all. Now, what's the interval for A? If the equation that we're solving is this, the interval should also be in terms of A. Now, how do you find the corresponding interval for A? What you do is you input the endpoints of theta inside the substitution. So what you would do would be, you would say, let's input 0 inside this. What's the corresponding value of A that you get? So if you input theta equal to 0 in A equals theta plus 60, what's the value of A that you get? 0 plus 60, that is 60. That means the lower limit for A should be 60. Then you input 360 in this substitution as the value of theta. What's the corresponding value of A that you get from that? 360 plus 60, what's that? That is 420. So the upper limit for A is therefore 420. So the interval for A now is 60 to 420. And now the problem is simplified to solving this equation for an interval from 60 to 420. Now, how do you solve this equation? You know how to do it. You find the basic angle. First of all, you say cos of alpha equals 0.85. Use your calculator to find the basic angle cos inverse of 0.85. This is in degrees. Make sure your calculator is in degree mode. Cos inverse of 0.85. What do we get from this? 31.79 degrees. That's the basic angle that I'm getting from this. 31.79 degrees. Okay. Now, once you have the basic angle, what do you do next? You draw quadrants. Which quadrants are possible? Cos is positive, right? In the original equation, the number on the right side, that is positive. Where is cos positive? Cos is positive in the first quadrant or in the last quadrant, fourth quadrant, ASTC, right? So you have to consider an angle either in this quadrant or in this quadrant. Okay, these are the two possible angles that you can have either in the first quadrant or in the fourth quadrant using ASTC. Now, where do we measure angles from? From the positive x-axis. So what you do now is you go in this direction. This is the first angle that you find. What's that? that is 31.79 degrees. But we have a problem. This does not fall in the interval that we have for A. Remember, we are solving for A. The interval for A is from 60 to 420. 31.79 is not in that interval, so we cannot consider that. Okay, it's outside the interval. Okay, so the first angle that we're getting, the first quadrant, we cannot use that because that's outside the interval. Okay, so what do we do then? We go further and we reach this next angle that we get. What's this? This is going to be 360 angle in a full circle minus the basic angle, which is 31.79. Put this on a calculator, and that is going to give you 328.2 degrees. That's one possible value for A that you get from this equation. Okay. Look at the interval again. The maximum value in this interval is above 360. That means it is possible that you can complete one full circle and come back to an angle that also falls inside the interval. So you also have to check that if you go one full circle and then come back here, what is this angle going to be? Let's write that down here. It's going to be 360 plus the basic angle, which is 31.79. That's another possible value of A that we're getting. Is that inside the interval as well? Yes, because this simplifies to 391.79 degrees. Let's keep this more accurate as well, because this is not a final answer yet. These are the values of A that we're getting: 391.79 and 328.21. These are the only two possible values that are in this interval. At this point, once we have found all the possible values of A, we put that substitution back, because remember, the original equation was in terms of theta. So we're looking for the values of theta. What we do now is we put that substitution back. A was theta plus 60. So we say theta plus 60 is therefore equal to this, or theta plus 60 is equal to this. And we find the values of theta from this. 328.21 minus 60 degrees, that will give you 268.2 degrees. That's one possible value of theta. And the other possible value would be 331.8 degrees. These are the two solutions that we get for this particular equation. If you had not adjusted this interval, you would most likely miss out on the second root that we found here, 331.8, because you would not go beyond one full circle. So it is extremely important that you adjust that interval first of all. And for that, using a substitution like this is going to make things easier for you. So how do we start? Whatever is the angle that is given inside, you substitute that with another letter. And that's what we started from. Using that, you adjust this interval as well for A. It was from 0 to 360 for theta. For A, it becomes from 60 to 420. And then you find the basic angle, find out all the possible angles in the given interval, in the interval for A, for the value for A, and then you find the corresponding values of theta from that. Is this process clear to everyone? Any problems with this? Any questions on this? So whenever you have anything other than theta or x inside the bracket, you would do a substitution like this, adjust the interval, and then solve it further using the same method. Make sense to everyone? Okay, let's take another example in this now. Now we can have a look at a couple of questions from the worksheet like this. For instance, let me choose one from here. One trigonometry. I think it should be there. Okay, let's try this one. This is question number 6 from the worksheet. Let's have a look at this. Question 6 from the worksheet. Okay, so we need to solve this equation. Sine of 2x plus 3 cos 2x equals 0. Now, again, you see the angle that we have is 2x. It's not just x, it's not just theta. It's being multiplied by 2. So x is multiplied by 2. Okay. So here as well, it'll make things easy if you do some substitution like we did in the previous example. Now, how do we start first of all? We have two functions. One is sine and the other is cos. We first of all have to convert it to a single function because right now we have two functions. Okay. We can't solve it as it is. So we have to use identities to convert it to a single function first of all. What are the two identities that we have? Sine square theta plus cos square theta, that is identical to 1, and tan theta is identical to sine theta over cos theta, right? These are the two identities that we have. Yes, so what we can do is we can divide by cos, right? There are two ways of doing this. You can divide the whole equation by cos. That's one idea, right? And then everything becomes tan, right? Cos and cos get cancelled here. On the right side, we have 0. This becomes tan, and that's it. That's all you want. That's all you want. Or another way to think about this could be that you first of all take cos to the other side. So it becomes minus 3 cos 2x. And then you divide this cos 2x on the other side. That's another idea. Almost the same, but a slightly different way of approaching that. You can divide cos to the other side. And that will give you sine 2x divided by cos 2x equals minus 3. Now, what is sine over cos? It is tan. So it becomes tan 2x equals negative 3. So we have converted that equation to something that is only in terms of tan now. So that's only one function. Okay. Now we need to solve this equation. The interval that we're given for x is from 0 degrees to 180 degrees. That's the interval for x. We need to solve this equation now. How can we do this? First of all, let's use a substitution. Convert this to some other letter. Substitute this with another letter. So you can say let a equals 2x. Okay. So that the equation becomes tan of a equals negative 3. Now, when you do this, you also have to adjust this interval. What is the interval going to be? A is between some values. How do you find those values? You input 0 in this. When x is 0, what's the value of a that you get from that? When x is 0, a is equal to 0 as well. When x is 180, what's the value of a that you get from this? 2 times 180, that is 360. So the interval for a, therefore, is from 0 to 360. Okay, interval for a is from 0 to 360. Okay, so that's a question that I often get when we have something like this. That can't we just cancel out the 2x here? Well, would that make sense? Can we cancel out the 2x here? Can anyone respond to that? So somebody's asking, can we cancel out the 2x from here? Right, we have 2x in the numerator, we have 2x in the denominator. Why don't they get cancelled out?
Sir, is it because they are multiplying with the sine cos?
Okay, first of all, they're not multiplying. That's the main confusion. If they were multiplying, we could cancel them out, right? They're not multiplying.
Sir,
that's the point. Yes.
Sir, the value of sine 2x and the value of cos 2x would be different.
Okay, they are different. That's all right. But they're saying just cancel out the 2x and 2x. Would that make sense? Okay, so that's equivalent to saying something like this. If you have, for instance, 2x whole raised to the power 5 divided by 2x whole power 2. Can we say just cancel out the 2x and cancel out the 2x here? And so that you're left with 1 inside, 1 raised to the power 5 over 1 squared, and that leaves you with 1. Does that make sense? We cannot do this. We cannot do this cancellation because 2x has this power 5, first of all, that we have to evaluate. In the denominator, we have this power 2 that we have to evaluate. Sine and cos are functions that are applying on 2x. you cannot do anything with 2x unless you first apply sine on this and you apply cos on this, right? You first have to apply these functions on this, and then you can do anything. So if you remember BODMAS from your previous years, this O represents two things. It represents indices. That's this, that you have to evaluate the indices first before you can do any division, multiplication, addition, subtraction. And it also includes any kinds of functions. This O thing, what basically means order, that includes these two things, indices, so basically powers of anything, and the second thing is functions. Sine and cos are functions that are applying on 2x. Unless you apply them first, you cannot do any multiplication, division, addition, subtraction with them. Okay, so first of all, sine will be evaluated, cos will be evaluated, and then you do anything after that. Does that make sense? Is that clear for everyone? So this has a higher priority. Okay. So we were here, tan A equals -3. Now we just solve this equation and see what we get from this. Find the basic angle. First of all, tan alpha equals 3. Put this on a calculator, tan inverse of 3. What do we get? Tan inverse of 3. 71.566 degrees. That's the basic angle. Now we draw quadrants. These are the four quadrants that we have. Tan is negative. Where is tan negative? ASTC, tan is negative here or here. Second or fourth quadrants, right? Now the basic angle here could be 71.56 in the second quadrant, or it could be in the fourth quadrant, 71.56 here. You start measuring the angle from the positive x-axis. The first angle that you get is this, and then the next one that you get is this. These are the two angles that we have. They're both in the interval from 0 to 360. Let's write them down. One is going to be A equal to 180, angle on a straight line, minus 71.56. That's one possible angle. And then the other possible angle is 180 plus 71.56. That's going to give you the other one. Okay, I'm sorry, this is not correct. We are in the fourth quadrant there. 360 minus 71.56. That will be the other angle. What's the first one? It is going to be 180.44, and the second one 288.44. Okay, these are the two values of A that we're getting. Now we put that substitution back. What was that? 2x. A was 2x, so we said 2x equals this or 2x equals this. That means x equals 54.2 degrees or x equals 144.2 degrees. These are the two values of x that we get from this, and these are our final solutions.
So one question.
Yeah.
The range is 360, so we cannot move forward to the second quadrant, right?
We cannot go one full circle and come back to that again, because that will go beyond 360. So we can't go like this. Is that what you're asking?
Yes. What would that be?
That would be 360 plus 108. So that's 468.4. That's outside the interval. So we only go beyond one full circle if the interval has angles greater than 360. Or in case of radians, if it's 2 pi, then you full beyond. Otherwise, you don't do that. Okay. Is that all right?
Yes, sir.
Okay, let's try another one now. Now things are going to get a bit more interesting, because now we'll do a question in radians, and that's going to complicate things a lot more. Now it's not from the works. I'm just writing something down here. Let's say you have a function like this. ASTC So we can get something in the negative. Yeah. So let's say you have cos of 3 theta minus pi over 4. That is equal to square root of 3 over 2. And the interval that you have is from 0 to, okay, just give me a second. Cos inverse of under root 3 divided by 2. What is that going to give us? 30. Will that fall in the interval? Yeah, okay. 0 to pi. Okay, so now we need to solve this equation. Cos of 3 theta minus pi over 4, that equals square root of 3 over 2. We want to solve this equation. Now, you can see from the interval that is given, this is supposed to be in radians. Okay. Now we need to solve this equation. What do we do with this? How do we start? Whatever is written inside the bracket, we substitute that with another letter, right? That's how we start. So we say let some other letter, let a equals 3 theta minus pi over 4. That's the substitution that we're using. Now, when we do that, we have to adjust the interval accordingly as well. So the equation is going to become cos of a equals square root of 3 over 2. That's the equation now. That's much simpler to solve. But what's the corresponding interval for a? Let's write that down as well. How do we do that? Input 0 in place of theta here. What does that give you? Minus pi over 4. When we input 0 here, we get 0 minus pi over 4. So that means the lower limit for a is therefore negative pi over 4. And then we input pi in place of theta. What does that give us? 3 pi minus pi over 4. Put that on your calculator. And that should give you 11 pi over 12. 3 pi minus pi divided by 4. That's 11 pi over 4. So when you input pi in place of theta here, the upper limit that you get is 11 pi over 12. Sorry, 11 pi over 4, not 12. Okay. Now we need to solve this equation for this interval. And then at the end, we would put that substitution back. How do we do this now? We find the basic angle. That's how we start. Cos of alpha equals square root of 3 over 2. Remember the basic angle that we find from the calculator, it has to be in radians. So convert radians, convert your angle to radian mode first of all. The angles are in radians, right? So you say cos inverse of square root of 3 over 2. Yeah, so that gives you pi over 6, right? So alpha equals pi over 6. In degrees, that is equivalent to 30 degrees, but we have to solve it in radians. So we use the radian value. The basic angle is pi over 6. Okay, cos is positive, right? Where is cos positive? Cos is positive in the first quadrant or in the fourth quadrant. So these are the two quadrants that are possible, first or fourth. Now the basic angle, pi over 6, could either be here or it could be here. These are the two possibilities, right? Now let's start measuring angle from the positive x-axis. This is the first angle that we get. What's this? This is pi over 6. So we say a is equal to pi over 6. That's the first angle. That clearly does fall in the interval, right? It's a very small positive value, so it is in the interval. What next? We can go further, and that makes us reach this point. This is also in the interval, right? Complete circle is 2 pi. Subtract from that pi over 6. So we have 2 pi minus pi over 6, and that simplifies to 11 pi over 6. That's the second angle that we're getting in the fourth quadrant now. Now, do we go beyond one full circle or do we not do that? How do we know that? Should we go beyond one full circle? Yes or no? 11 pi over 4 If you convert that to decimal, that is 2.75 times pi. 11/4 is 2.75. 2.75 pi. That's greater than 2 pi, right? So you can go one full circle and come back again. It is a possibility that you get an angle inside this interval after completing one full circle as well, because this is going beyond 2 pi. So let's do that now. Let's go one full circle and come back again. So we can go like this and then come back to this point. That's another possible value of A that we have. Let's write that down as well. What would that be? One full circle is 2 pi plus pi over 6. That's another possible value of A that we have. This is 13 pi over 6. You can check if it is inside the interval as well, again, by converting it to decimals if you want. 13 divided by 6 is 2.16. Is that in the interval? Yes, the interval is going up to 2.75 pi. We have 2.16 pi. So this does fall in the interval. So that's another possible value of A that we also consider. Okay. So that's another value. You can keep going on like this. You can say complete one full circle. So that's 2 pi plus this angle, the one in the fourth quadrant. So essentially that would be 11 pi over 6, this angle, plus 2 pi. So if you add 2 pi to this, what do you get from that? That will give you 23 pi over 12. That is going to go outside this interval. You can check that by converting it to decimals. It will be something very close to 4 pi, 3 point something, right? So 3.8 something pi, I think. You can check that. That is clearly outside the interval, so that is not something that we can consider then. So the only three angles that we get therefore are these three in the positive direction. All right. Okay, what do we do next now? The interval also has negative values, negative pi over 4. So that means it is a possibility that if we go clockwise, we can get some other possible answer as well. So we also have to check that. Let's go in the clockwise direction now. This is the first angle that we get in the clockwise direction. Is that in the interval? Let's check that. A equals negative pi over 6. Negative pi over 6, the interval is going up to negative pi over 4. Is that in the interval or not? Negative pi over 4 is basically negative 0.25 pi. And this is negative 0.167 pi, I think. You can put this on your calculator, 1 over 6. And this is 1 over 4. Is this inside the interval or not? It's bigger than negative 2.25, right? Negative 0.25 is smaller number. Negative.
Yes.
1.167 is a bigger number. So this does fall in the interval as well. Or in fact, you can compare this directly as well. 1 over 4 is clearly bigger than 1 over 6, right? Okay. So that's another possible value of A that we're getting. If you go further, we'll go outside the interval. So these are 4 possible values of A. Now we put that substitution back. What was the substitution? 3 theta minus pi over 4. Let's put that back here now. We get 3 theta minus pi over 4 equal to pi over 6. That's one possible answer. Then we say 3 theta minus pi over 4 equals this. And then 3 theta minus pi over 4 equals this. And then finally, 3 theta minus pi over 4 equals this. These are the 4 possible angles that we will get. We can solve each of these equations now. Find the value of theta from this. Pi divided by 6 why is it so slow? Pi over 6 plus pi divided by 4 and then this whole thing divided by 3, right? That will give me the value of theta here. This is 5 pi over 36. That's the first possible value of theta that I'm getting. And the second one, this is now 11 pi over 6 plus pi over 4 divided by 3. And that is 25 pi over 36. That's another possible value of theta. Then in place of 11, now we have 13. So that's 29 pi over 36. That's another possible value of theta. And then finally, we get theta equal to, sorry, this was negative pi over 6 here. Negative pi over 6 plus pi over 4 divided by 3. And that is giving me pi over 36. These are the 4 possible values of theta that I'm getting: 1, 2, 3, and 4. And these are all possible solutions of this equation. This is as complicated as it can get in questions like these. If you understand this, hopefully you will be able to do all such problems. And you can see the final solutions that you're getting, they will automatically fall inside the given interval in the original question, right? So when you follow this process correctly, the values of theta at the end, they will themselves fall inside the given interval from 0 to pi. So all of these values are between 0 and pi, right? And these are our final solutions. Any problems with this? Questions on this, anyone? No problems? Okay, what I'm going to do now is I'm going to give you a question to try yourself. We will just do this one last question on this, and then we'll do another concept after a short break. Let me find one from the worksheet. Yeah, this one. Question number 44. Let's try this last one. The second part is very similar to the that we have just done. So I will give you a few minutes to try this yourself. Question number 44. Okay, I'll give you a hint about the first part. It says find the possible values of x for which sine inverse of x squared minus 1 is equal to pi over 3. Giving our answers correct with 3 decimal places. Now it says sine inverse of x squared minus 1 is pi over 3. How do we start first of all? We take sine inverse to the other side, right? Because sine inverse of x squared minus 1, that is not something that we can evaluate, right? We have an x here, so we can't really evaluate it. We have to take sine inverse to the other side. Now, what happens when we do that? We get sine inverse of x squared minus 1, that equals pi over 3. Now, first of all, we simplify this equation a bit by taking sine inverse to the other side, so that it becomes x squared minus 1 equals sine of pi over 3, right? It was sine inverse on the left side. When you take it to the right side, it will become sine. Now, what is sine pi over 3? You can put this on your calculator. Make sure your calculator is in radian mode. Sine of pi over 3, that should give you under root 3 over 2. That's what you're getting. Now you just solve this equation. Okay, so we're almost done. So let me just complete this. 1 plus square root of 3 over 2. Add 1 to it. They want an answer in decimal form. So you can just use decimals already. This is going to give you 1.866025. Use more accuracy because it's not your final answer yet. And then when you take square root of this, that gives you 1.366 to 3 decimal places. But remember, whenever we take square root, we have to put plus minus. So this is plus minus 1.366. These are the solutions to the first part. That's pretty straightforward. The question also tells you find the possible values of x. Okay, so that means there had to be multiple solutions. So if you're getting just one answer, looking at the question statement again should remind you that there should be multiple answers. So you should put plus minus there. Okay, so that's part A. Now part B is very similar to the question that we just did previously. I will give you a few minutes to try this. Part B, let me know the solutions that you get. I'll take a short break. And when I come back, I would expect that you would have solved this by then and written down your solutions in the chat. Please try this quickly and let me know the solutions. Second part.
Sorry, you're muted.
Your mic is muted, sir.
Okay, I'm sorry about that. You guys could not hear me. Let me redo this. You guys can hear me now?
Yes.
Okay, I'm really sorry about it. I thought मेरी आवाज सबको आ रही है. You could not hear me at all before?
Not at all. Even though we were telling you that we cannot hear you, but I don't think you could even hear us.
Oh, okay. So I think my audio was not connected. I got disconnected while I was away, and then I think when I rejoined, I could not hear anyone after that. Okay, I'm sorry about that. So now you can hear me. Okay, all right. I could not hear any of you as well. Okay, sorry. I'll just redo all of this. All right, so this is the equation that we're solving. Sine of 2 theta plus pi over 3 equals 1 over 2. And theta is between 0 and pi. Okay. Okay, I could read your messages, but I could not hear any of you. Okay, sorry about that. अभी message आया तो मुझे पता चला कि किसी को नहीं आवाज आ रही. All right. Sine of 2 theta plus pi over 3 equals 1 over 2. Theta is between 0 and pi. We need to solve this equation. How do we start? We start by using a substitution. We say let A equals 2 theta plus pi over 3. Okay, we can start like that. And then this equation becomes sine of A equals 1 over 2. We have to adjust the interval accordingly as well. What would that interval be? We put 0 in place of theta. 0 plus pi over 3, that would be pi over 3. Then we input pi in place of theta. That becomes 2 pi plus pi over 3, right? 2 pi plus pi over 3, that will be 7 pi over 3. You can put that in a calculator. Now 7 pi over 3 is the same as 2.33 pi. Okay. So in case you can find an angle inside the interval by going beyond one full circle, you also have to consider that possibility because this is greater than 2 pi. Okay. Just keep that in mind. What's the next thing we do? We find the basic angle. Sine of alpha equals 1 over 2. Find the basic angle from that and see what that gives you. Sine inverse of 1 over 2, put that in a calculator. Your calculator should give you pi over 6 for this. Okay. Now we use quadrants. We use quadrants and that gives you something in the first quadrant or in the second quadrant, right? It can be in any one of these two quadrants. It could be pi over 6 in the first quadrant or pi over 6 in the second quadrant. Okay. These are the two possibilities that we have. Now we find now we find all the possible angles inside this interval for A. Now let's start with the first angle that we get in the first quadrant. This is pi over 6. So we could say A is equal to pi over 6, but notice this number is less than pi over 3. Pi over 6 is less than pi over 3, so we cannot really consider that because it does not fall in the interval. Pi over 6 is less than pi over 3, right? So that does not work. It's outside the interval. So we cannot consider this angle in the first quadrant. We have to ignore this. We go further to the second quadrant. What's that? Angle on a straight line is pi. Pi minus pi over 6, that gives us 5 pi over 6. That's the first value of A that we get inside this interval. All right. That's one value of A. Then we can go further. Since the interval is going beyond 2 pi, that means we can complete one full circle and possibly come back to another possible answer. So that's what we do. We complete one full circle and come back to the first quadrant. This angle, what would that be? One full circle is 2 pi plus pi over 6. So A could equal 2 pi plus pi over 6, which is going to give you 13 pi over 6. That's another possible value of A that we get. Now we need to check if this is indeed in this interval or not. Now you can either do that by converting it to decimals. You put this on your calculator, 13 divided by 6, that is 2.16, 2.17. So this is 2.17 pi. This is less than 2.33 pi. That means it does fall in the interval as well. Okay, so this is another possible value of it. Or you could also compare it like this. You could multiply this by 2. That's going to give you 14 pi over 6, right? Multiply the denominator and numerator so that the denominators become the same. And then you can compare them. 13 pi over 6 is less than 14 pi over 6. So it does fall in the given interval as well. This is another possible value of A. Now, since we're already very close to this upper limit, if we go beyond this and get to this angle by after completing one circle, we will go outside the interval. You can check that as well. That will be outside the interval. So these are two values of A that we're getting. Now we put that substitution back. 2 theta plus pi over 3, that either equals 5 pi over 6 or 2 theta plus pi over 3, that equals 13 pi over 6. Find the possible values of theta from this. The first one is going to give you 5
over 4.
Pi over 4. Okay, the first one gives us pi over 4, and the second one?
11 upon 12 pi.
11 pi over 12. These are the two possible values of theta that we get for this equation. All right, these are the two solutions that we have. No problems? Make sense to everyone? All right, good. Now let's continue to the next concept that we have. That's a small one. We will try to complete this today so that in the next class we can talk about graphs of trigonometric functions. Okay, so you must have seen questions like this in the worksheet as well, where they give you one possible angle like this. For example, in question number 43, they give you one possible ratio. For example, they've given you cos here, and they want you to find the other functions, sine, tan, etc. This is question number 43 from the worksheet. It says cos of x is equal to p, where x is an acute angle in degrees. Find in terms of p, sine x, tan x, and tan of 90 minus x. Okay, so given cos of x, we need to find these other three functions. Now, there are two ways of approaching problems like these. You could do this using identities. That is one idea. Most of the parts can be solved using identities. There are some parts for which you would have to think a bit more. And for that, we have to use another method. So we have two different methods. I would generally recommend that you use this second method, in which we do not use identities. So I'll start with that first. We'll do some questions using that, and then I'll tell you about the one in which we can use identities as well. Okay. So here's one way to think about this. They have given you that cos of x is equal to p, and x is an acute angle. If x is an acute angle, that means x is between 0 and 90. Between which two quadrants is, in which quadrant is that? It's 0 to 90, right? That's the first quadrant. So the angle x is therefore going to be in the first quadrant. So if I were to draw it here like this, I could draw a triangle like this in the first quadrant. This angle is the basic angle. In this case, the basic angle is the same as the angle x. This is also x. Right? In the first quadrant, x is equal to alpha. Basic angle and the angle itself, they're both the same. Now we are given that cos of x is equal to p. What's the definition of cos? How do we define cos? We can use any of the two definitions that we have done. X over r that we did when we started trigonometry here in A levels. We defined sine, cos, and tan using these new functions, right? Using these new ratios. Instead of base, we started calling it x in place of perpendicular. We said that's y coordinate of the point. In place of hypotenuse, we said that will be called the radius. You can either use that definition, or if that confuses, you can use the previous definition as well. Just remember that base can be negative and perpendicular can be negative in this context, because on the left side, the x coordinate is negative. So base would be considered negative, and below the x-axis, y coordinate is negative. So the perpendicular will be considered negative. Just keep that in mind. Now, how is cos defined? Cos is defined as base over hypotenuse. Base over hypotenuse. We are given that cos x is equal to p, and the definition of cos is base over hypotenuse. We can write p as p over 1, right? That's the same thing. If the ratio of base and hypotenuse is p, that means it's p over 1, right? P to 1. So if base is equal to 1, if base is equal to p, hypotenuse will be equal to 1. So if this base is p, this hypotenuse has to be 1. Okay. Now, if that is the case, can we find the perpendicular? The height there, we can find that using Pythagoras. We can say perpendicular squared plus base squared equals hypotenuse squared. And that is going to give you perpendicular equal to square root of 1 minus b squared. So this side turns out to be square root of 1 minus b squared. Does this make sense until this point? Because once you've done this much, then the rest is going to be straightforward. Once you've made this triangle, written down all the sides of this triangle, the rest is going to be fairly straightforward after this. Any problems until this point? No problems. Cos was equal to p. The definition of cos is base over hypotenuse. So we said the ratio of base and hypotenuse is P, which is the same thing as P over 1. So if base is P, then hypotenuse is 1. Using these two values, we can find perpendicular as well. So now we have this right angle triangle in the first quadrant, for which we can find sine, tan, and tan of 90 minus x now. How can we do that? Sine of x, what is that going to be? Sine is defined as perpendicular over the hypotenuse, right? What's perpendicular here? Square root of 1 minus b squared. What is hypotenuse? That is 1. So sine turns out to be square root of 1 minus b squared. And then in the second part, they ask you for tan x. How is tan defined? Perpendicular over the base. So what is this going to be? Square root of 1 minus b squared divided by b. That's the second part. Okay. And then in the third part, they ask you for tan of 90 minus x. Tan of 90 minus x. What about this now? Any idea how we could find this? Tan of 90 minus x?
So if we use substitution,
If we use substitution, okay, let tan of 90 minus x, we put that as a. What do we do then? How do you find its value? Substitution we do when there's an equation, right? So in the previous examples that we did, we were solving some equations. To solve those equations, it becomes simpler if we substitute this thing with another letter. Whatever is the angle, you substitute that with another letter. But we're not solving an equation in this case. We have to find the value of tan of 90 minus x. Is there an angle in this triangle which is 90 minus x? Okay, so it's not the same as tan of 90 minus tan of x. It's not the same. Again, tan is not multiplying with this, that we multiply tan by 90 and then we multiply tan by x. We can't do that. That's not how it works. This whole thing, this first has to be evaluated. 90 minus x, there's subtraction inside brackets. So brackets have to be evaluated first. And then you apply this function after that. So we can't break it like this. That does not work. What's the total angle in a triangle? 180 degrees, right? It's a right angle triangle. This angle is 90. If this is 90 and this is x, what about that angle on top there? What would that be? The remaining two angles, apart from the right angle, their sum is 90, right? So the angle on top there, that is supposed to be 90 minus x. Okay, so in this right angle triangle, that angle on top, that is 90 minus x. Now, from the perspective of that angle, what's the tan? The opposite side would be this, and the adjacent side would be this. So what does this become then? It becomes tan of 90 minus x equal to the opposite, which is p here, and adjacent, which is this. So tan of 90 minus x, therefore, is p over square root of 1 minus b squared. That's what we get. Is this all right?
can you again explain about 90 minus x by writing?
Total angle is 180. Subtract from that this 90. Subtract from that this x. What are we left with? 180 minus 90 is 90. 90 minus x. So this angle on top has to be 90 minus x. Okay. So if this angle at the bottom is x, that angle on top has to be 90 minus x. Make sense?
Yes, sir. Good.
Okay, now this is one way of approaching problems like this. We make a right angle triangle using the quadrant that we have in the question. This is an acute angle, right? So that's the first quadrant. How do we get p over square root of 1 minus p squared? This is the angle, right? 90 minus x. From the perspective of this angle, what is tan? Tan is opposite over hypotenuse, right? So with respect to the angle 90 minus x, the opposite is p, and adjacent is this side. So that's what we have, right? Okay. So that's tan of 90 minus x. That's one way of approaching this. Another way of approaching this question is using identities. For that, there are some identities that you should definitely remember, but there are actually like 11, 12 more identities after that, which I don't think is a good idea to try to memorize, although there's a way to memorize them, but it'll confuse you if you do not understand the logic. So I would want you to do it using this method that we just discussed. However, there's another method, I'll just tell you about that as well, and that is using identities. There's another set of identities that we have, apart from sine square plus cos square equals 1 and tan equals sine over cos. These are called complementary angle identities. Now, what are complementary angles? Complementary angles are angles that add up to 90. Complementary angles are angles that add up to 90. So if you have one angle x and another angle y, their sum is 90, then x and y are complementary angles. We have some identities for such angles. And they look like this. Let's understand them using a right angle triangle. So let's say we have a right angle triangle like this. In this triangle, if we say the angle at the bottom is theta, and this is a right angle, then what about the angle on top? What would that be? Angle on top?
90 minus theta.
It will be 90 minus theta, right? Let's call these sides something A, B, and C. Now, if we find sine of, or let's say cos of theta, what is that going to be? Cos of theta, A over C. Cos theta is A over C. Adjacent over the hypotenuse. Sine of theta, that's opposite over hypotenuse. That would be B over C. And tan theta, that would be opposite over adjacent, which is B over A. Okay. So these are cos, sine, and tan. Similarly, if I were to find these ratios with respect to the angle on top, which is 90 minus theta, what would those ratios be? Sine of 90 minus theta. Opposite in that case would be A. Hypotenuse would be C. So we get A over C. For cos of 90 minus theta, adjacent is B. Hypotenuse is C with respect to the 90 minus theta angle. So that becomes B over C. And tan of 90 minus theta, that will be opposite, which is A, adjacent, which is B. That becomes A over B. Now you notice the connection between these ratios. These two are same. These two are same. These two are not the same, but they are reciprocal of each other. So from this, we actually have three identities that look like this. Sine of 90 minus theta, that is identical to cos of theta. Cos of 90 minus theta is identical to sine of theta. And tan of 90 minus theta is identical to 1 over tan theta, right? It's the reciprocal, so we can say that's 1 over tan theta. These are three new identities that we have now. They're not given in the formula sheet. You should remember them. Okay. Sine of 90 minus theta is cos theta. Cos of 90 minus theta is sine theta. Tan of 90 minus theta is 1 over tan theta. Although these questions that I just showed you, they can be done without these identities as well. But these three identities are important because we will need to use them later on in mechanics as well, and in other parts of pure math syllabus as well. So these are important. This is what the identities are going to look like in degrees. You could write down their corresponding identities in terms of radians as well. So you can say sine of pi over 2 minus theta would be equal to cos theta, identical to cos theta. Cos of pi over 2 minus theta, that would be identical to sine theta. And tan of pi over 2 minus theta, that would be identical to 1 over tan theta. So you can write those three identities in terms of in radians as well. All you have to do is in place of 90 degrees, you write pi over 2. So these are some new identities that we have. You should remember them. Using these identities, you can solve problems like those as well that I showed you. Okay. Now let's see how that would work. Let's go back to that same example, question number 43. Another way to approach this could be using identities. Now, how would that work? Let's look at the first part. Cos of x equals p, and it's in the first quadrant. It's from 0 to 90. One way to approach this could be using identities as well. How would that work? You're given that cos of x is p. What you have to find out is sine x. Now, what's the connection between sine and cos? We know that sine square x plus cos square x is equal to 1. If cos x is p, we can input that here. And that gives us sine square x plus p squared equals 1. And then sine square x equals 1 minus p squared. Take square root on both sides. You get sine x equals plus minus square root of 1 minus p squared. But now we know that x is in the first quadrant, right? It was an acute angle. It's in the first quadrant. So we only consider the positive value of sine because in the first quadrant, we know that sine is positive. So sine x therefore equals square root of 1 minus p squared. Okay, that's what we could do in the first part here. Then in the second part, they ask you for tan of x. What is tan? We know that tan is identical to sine x over cos x. Sine is this, what we have found here, square root of 1 minus p squared over cos, which is p. So this is what tan x becomes. And then part 3, in which they ask you for tan of 90 minus x. What's that? We just did an identity for this. Tan of 90 minus x. That's what they're asking for in the last part. What would that be?
1
Tan
upon
90
tan
minus x
theta.
is 1 over tan x, right? Now, we just take reciprocal of this. So if tan x is this, 1 over tan x would be reciprocal, which is p over square root of 1 minus p squared. This could be another method for this particular problem as well, using identities. Okay? No problems?
So I have a question.
Yes.
So can we not use the identity tan theta is same as sine upon cos, and then we shift the cos to the other side? Can we not do that?
For what?
So sine to solve, like not using the identity sine square x plus cos square x.
So if we only know cos, and then we do sin x equal to tan x into cos x, we don't even know tan. How will we find sin for that? From that, we found tan by using the value of sin, right? So we first found sin and then use tan as sin over cos. So if we don't know sin first, how would we know tan in this?
Got it.
Okay, all right. But this is another method that you could use, but the problem is sometimes you end up getting some other angles inside the bracket. Just one last example very quickly, 49. In this case, you see the last part of this question, it has sine of theta plus pi. Now, if you use identities, then there are too many identities to remember. You have identity for 180 minus theta, just like we did a few for 90 minus theta. You can have them for 180 minus theta, 180 plus theta, 360 minus theta, and then the same identities in terms of radians. You'll have to remember all of them, and then you can use those identities for this 1 mark quiz. Okay. Or the alternative is to use that triangle method that we just discussed. So that's why I would recommend that you just use the triangle method. So in this case, if the angle theta is obtuse angle is from 90 to 360, but this is in radians. So we would say this is from pi over 2 to pi. It's in radians such that sine theta is equal to k. Find an expression for cos theta, tan theta, and sine of theta plus pi. Now, how do we think about this again? We can make a triangle like this. Okay. Now, it's an obtuse angle. Obtuse angle means we are in the second quadrant now. Second quadrant. So the angle is going to be here in the second quadrant. This is the angle theta, right? We measure angle from the positive x-axis like this. All right. And then this is the basic angle inside. That basic angle determines the base, the hypotenuse, the perpendicular. So with respect to this basic angle, this is the base, this is the perpendicular, this is the hypotenuse. We are given that sine of theta is equal to k. That's what we're given. So how do we start? First of all, we find all 3 sides of that triangle. Let's find those 3 sides. Sine is defined as perpendicular over hypotenuse, right? The old definition, perpendicular over the hypotenuse. That means the ratio of perpendicular and hypotenuse, what should that be? That should be k. So we can say that's k over 1, which means if perpendicular is equal to k, then hypotenuse is equal to 1. We can write those values here on this triangle. If this side is k, the perpendicular is 1. What about the base then? Using Pythagoras, we can say base squared plus k squared should equal 1 squared.
I cannot hear you.
Okay, I'm sorry. Something is wrong with my connection today. Can you hear me now? And also see my screen?
Yes, sir.
Can you see my screen moving?
No, screen was not moving.
Okay, so let me share it again. Okay, what about now? Okay, I think
Yes,
it's
yes,
good.
sir.
Okay, sorry about that. So what were we doing? You understood until sine theta, right? You guys could hear me until that point? Sine theta was
Yes.
true. And we found the base from that. Now, since the base is in the second quadrant, you could consider it negative if you wanted. So you could say this is negative, right? Because the x coordinate is negative. Or even if you consider it as it is, just remember it's the second quadrant. In the second quadrant, cos is negative and tan is negative. So your final answers for cos and tan, they should be negative. Only sine is positive in the second quadrant. Okay. Now what's cos going to be? Base over hypotenuse. Base is this. Square root of 1 minus k squared over the hypotenuse, which is 1. But since we're talking about cos, it's the second quadrant. It is supposed to be negative. So that's minus square root of 1 minus k squared. That is cos. And then the second quadrant, that is tan. What is that? What's that supposed to be? Tan theta. Perpendicular over the base. That is k over square root of 1 minus k squared. Again, we are in the second quadrant. That's supposed to be negative. We put a negative sign with that. And then finally, this is a tricky one. Sine of theta plus pi. How do you find this now? Sine of theta plus pi. Where is this going to be? Theta is in the second quadrant, right? It's an obtuse angle. What you're doing is you're adding pi more to that. Pi is 180 degrees, right? Pi means you're adding 180 degrees essentially. When that happens, you end up going to the fourth quadrant, right? Because this will be theta plus pi. This here would be theta plus pi because theta was obtuse in the second quadrant. No, they're not talking about the basic angle. Theta is an obtuse angle, right? Theta is the obtuse angle. That's this angle theta outside. You add pi to that. So add pi more to that. That will take you to the fourth quadrant. When you go to the fourth quadrant now, you notice the basic angle here is still going to be the same because these are now vertically opposite angles. This angle and this angle, these are vertically opposite angles. The basic angle is still the same. If the basic angle is the same, that means all the sides are going to be in the same ratio. Perpendicular is k, hypotenuse is 1, and the base is square root of 1 minus k squared. So it's the same triangle there with the same sides, but now we are in the fourth quadrant. Since we are in the fourth quadrant, sine is negative in the fourth quadrant. Its magnitude will remain the same because that's still perpendicular over the hypotenuse. That is still k. But since we're in the fourth quadrant, it will become negative. So we can say sine of theta plus pi is negative k because of being in the fourth quadrant. Okay. So when we add pi there, we get to the fourth quadrant. The basic angle remains the same. That means the ratio is going to remain the same. The only difference is the plus minus changes. In the fourth quadrant, sine is negative. We put a negative with that because of that reason. Is that okay? Any problems with this? All right, I hope that makes sense. Now, please make sure you attempt all the assigned questions from the worksheet apart from graph questions before the next class. You have a couple of days now. On Wednesday, we will discuss graphs and some practice questions on that. and we'll try to wrap this topic up on Wednesday, inshallah. All right, that's it for today. I'll see you again in the next class. Allah Hafiz.